There is perhaps no better analytical way to determine if an initiative actually is having an impact on a metric than conducting a robust A/B test. Hi, I'm Brian Amrine with Value Driven Analytics, and in this video, we'll go over a critical skill to have as a data analyst, and that is being able to conduct a robust A/B test. An A/B test is essentially a scientific experiment. You randomly select a test group, and the remainder of your observations are considered your control group. And the random assignment is absolutely key. That will ensure that in aggregate, the two groups, especially with enough volume, are exactly the same. With that said, let's head over to our PowerPoint to learn more. A/B testing, one of my favorite topics because it is absolutely the best way to determine if an initiative is working. It's also known as a scientific experiment. That's essentially what we do when we take a group of observations, which could be people or products or geographies, as we said before, and randomly assign about half of them to a test or treatment group and half of them to a control group. Now, it doesn't have to be half. In fact, if you're really not sure this is going to work, you might go with a 20% or 10% group, especially if you have a large number of observations. That should be fine. Or in some cases, people are very confident. They want to have a holdout population to know the impact of the change, and they might go with 80, 90% in the treatment group and 10 or 20% in the holdout group. But you'll get the absolute best read on the test if you take 50% of the population and assign it randomly to the treatment group or the test group and the remainder to the control group. The great thing about this approach is that the only thing that is different if they are truly randomly assigned to the test and control groups is that the treatment will be applied to the test group, which means that when you observe the differences across the two groups, any differences, especially if they're statistically significant, can be applied to the treatment. It is a very robust approach. There's no selection bias through the random selection process. Now, what you might do, especially as you even as you start to design the A/B test, maybe you've randomly selected the test and control group, and you just want to be sure that it was absolutely random. You can use Excel random generation or Python random generation, but you want to be sure that these two groups are truly random. What you might do is select the groups and then plot out their performance in the metric that you want to measure, like sales, for instance. Monitor what the difference has been over time. And what you should see is that the two groups are essentially lockstep over time. So again, we're doing a trending analysis here, and you will see some natural variation, some randomness in there. So in this case, in this particular month, the control group performed a little bit better than the test group. And that was the case for the next month too. And then the test group performed a little bit better. But what you should see is that there's not a consistent difference across the two groups, especially prior to introducing the treatment. So in this case, there's a month when the treatment gets applied, maybe it's July 2022 in this case, and that's where we're really interested in what happens next between these two groups. What happens to the test group? In some cases that we want the metric to go up, in some cases the goal could be to bring a metric down. Whatever it is, what we should see is that there starts to be some separation across the groups if the treatment is actually having some kind of an impact. And so in this case, we see that the two groups are pretty much in lockstep. A treatment gets applied, and then, especially after 2 to 3 months, we start to see a consistent difference between the two. Now, we would want to go and do a t-test to make sure that difference is statistically significant, but at least visually you can see there is a consistent difference where the test group is consistently performing higher than the control group, whereas before we introduced that treatment, they were pretty much performing at the same level. So just visually looking at this, I would be pretty confident about saying that the treatment had at least some impact on average sales per customer. This is a great visual to show to an executive to prove that this treatment had an impact. Now, at the end of the A/B test, we'll want to assess the difference between the test and control groups before the test, pre-test, and post-test. We might create a visual like this that highlights the overall differences during those two time periods. In this case, since the test started, the treatment was introduced to the test group in July 2022. Our pre-test period, January 2022 through June 2022, we saw a very minor difference across the groups. They were randomly selected, and so there shouldn't be a very large difference. There'll always be somewhat of a difference due to random variation, but in this case we could see that the test group, their average sales per customer was 98.5 versus the control groups was 100.3. So the test group was 1.8% lower in terms of average sales per customer than the control group in the pre-test period. We want to compare that to what the difference was like in the post-test period, in this case July 2022 through February 2023. And during that time period, we actually saw that the test group was 21.6% higher in terms of average sales per customer than the control group. So what we might do is, if we thought that there was a possibility, there was a systemic difference, we might control for the pre-test difference of negative 1.8%, subtract that out from the difference we saw in the post-test period, and what we would suggest is that the treatment introduced in July 2022 to the test group had the impact of increasing sales per customer by 23.4%. We can also see this visually. We saw the over time visual, but sometimes it's nice to see things aggregated up by time period, by test group or control group. We see again during the pre-period the groups are very similar in terms of average sales per customer, and post-period the groups are quite different. The test group is clearly higher than the control group. So that's another way of visually showing what the impact was. Now another thing, and before we move on, we would want to conduct perhaps a t-test, a statistical test, to determine whether that difference was statistically significant. Now you might also decide to build a data science model that could, one, be used to determine whether there's a statistical significance. So you could do a t-test, but you could also set it up as a regression model, and your target variable would be whether or not a customer was in the test group, and you'd be seeing what impact that had on sales per customer. That's another way of measuring the statistical significance. If the p-value of that is the observation in the test group or not, if the p-value of that coefficient is positive and is statistically significant, yes, we did. We had an impact and it's statistically significant. Now another thing you can do, especially if you get into a response model, a mixed model that has interaction variables, is you might be able to assess whether, not just whether there's an overall positive impact or negative impact of a treatment, but whether that treatment impact varies depending on other characteristics. Maybe the treatment works really well in a certain characteristic or a certain profile of customer, and not so much in other profiles. You can use interaction variables to assess whether that's the case. All right, now it's time to take what we've learned and actually apply some of these concepts to example requests that you could face as an analyst. First question that you might get perhaps from an executive, and might get a request like this: I'd like to have some visibility into how our sales are performing. If you were to get that request, how would you approach it? What techniques would you use? How would you set it up? Let us know. Or how about if you got this request from perhaps a marketing stakeholder? I'd like to understand if geographic areas where we spend more on marketing typically see more sales. That might help you assess whether your marketing is working or not. How would you set that up? What techniques that we've talked about would you potentially be able to use to provide an answer to that question? This is a challenge that is probably all too common for sales teams. So a sales manager might approach you with the following challenge: Today, each of our salespeople have about 1,000 customers in their territory that they could potentially call or visit. Each salesperson has their own way of determining when and which customers to visit and how often, but I feel like we should be able to give them some kind of recommendations based on data. Is there any way we can use analytics to help them? How would you approach that? What techniques that you learned about today could potentially be used to solve that problem? Okay, last one. How would you address this request? We're planning on launching a new online marketing campaign where we'll send follow-up ads to visitors on our website. We'd like your help to analyze the campaign. What techniques could you potentially use to measure that? Learning concepts is great, but where you really learn is when the rubber meets the road and you actually apply these concepts to real situations. So before you watch the next video, I highly recommend thinking through how you would address each one of these requests. And if you're brave enough, maybe leave your approach in the comment section. In the next session, we'll start off addressing these, and I will give you at least my approach for how I would typically handle these. Now, there could be multiple robust approaches, but hopefully we can collaborate on a solution for our 4 stakeholders here. Now, you might be asking the question, what happens after all 7 sessions are over? Where is that going to leave me after I've made that kind of investment of my time? Well, for those of you that are passionate about pursuing a career in analytics, you can use the recommended resources after each session to keep learning and dive in more to a particular topic. This training series should provide you with really good context that'll better prepare you to dive in and learn more about each topic. Okay, ready for your homework? In addition to thinking about your answers to those 4 potential analytics use cases, I'd like you to brainstorm a way of using analytics at your organization or even in your personal life, whether it's your finances and planning expenses, or maybe a hobby of yours like a particular sports team that you follow. Whatever it is, think of some good ways of using analytics and applying it to a use case. That is going to be a big way that you can stand out compared to other analysts if you have the ability not just to complete an analysis when it's given to you, but also recommending what's possible with analytics. So have a shot at that. I want to thank you for watching today. I know it's a time investment, but I hope you've gotten a lot out of it. And if you have, please consider liking the video. And if you'd like to see more training videos like this, please consider subscribing to our channel. Hopefully we'll see you at our next session on Excel data manipulation. It's going to be a good one. And if you'd like to learn more about how value-driven analytics can help your organization drive value with data, please visit us at valuedrivenanalytics.com or consider calling us at 1-877-825-3786. That's 1-877-VALDRVN. We'd love to talk to you.